Okay, you ready? So if you pay attention to the number of slides, there's a lower number today. We're going to add and subtract, and then we have to deal with something called a complex fraction. And that's it. You know, adding and subtracting is generally more difficult because it involves finding common denominators. And common denominator is hard enough when you don't have variables involved. When you do have variables involved, it gets a little harder. So we will systematically do these three things: add, subtract, complex fractions. So when you add or subtract, right, it makes a difference if you already have common denominators, the same denominators. Then it's like adding fractions, right? If I add 3/5 plus 4/5, if they already have the same denominator, you just add the numerators. Right? That's 7/5. The same thing will be true when we have variable expressions in the denominator. It may seem like a trivial point, but after we do all of the factoring and everything that we do with non-common denominators, when we're presented sometimes with the same denominators that already has common denominators, sometimes we get stuck. So these are the directions. Just add and subtract the numerators, and if there's some simplifying to do, then simplify. And by simplify, what do we mean? I mean, if there's common factors in the numerator and denominator, cancel them, right? Okay, Prash? No, you don't have to draw the little hand. Okay. So, for example, they already have the same denominator, 4x. So we add them by adding the numerators, 10, and you don't change the denominator, right? Just like we did with the example on the last slide. It doesn't change the denominator when you add the numerators. It's still 4x. Now, can that be simplified? What's the common factor? 2. 5 over 2x. Okay, the second one. They already have the same denominator, so subtract the numerators. 2x minus 5. Any simplifying looks like you could do? Nope. I mean, you can't say 2x over x is 2. No, you can't. Okay, so try that one. That's your you try. So what was the answer? 1 over 6x, right? Because it was 2 over 12x. Do that one. Numerators. Get it? Okay, if they don't have the same denominators, then you have to find a common denominator. And then once they do have common denominators, you will add or subtract the numerators like we did already. Good. Now, how to find the least common denominator. First, factor the denominators of both fractions. The least common denominator will have every factor that you see in either denominator the most times that you see it. So, for example, if one fraction has x plus 3 and the other fraction is x plus 3 squared, then the common denominator has to have x plus 3 squared. It has to have it the most times you see it in any one particular denominator. You don't say like x plus 3 is once there and twice there, so there it's 3 times. Right? It doesn't add. Just look for whichever fraction has it the most times. That's how many times it's in the least common denominator. Once you've figured out the least common denominator, then you're going to have to multiply so that each fraction has that denominator. I mean, it's completely kind of like if I said, what if I said 1/4 plus 1/6? Right, this is 1 over 2 squared. This is 1 over 2 times 3. That was wrong. So I would say that the least common denominator has to have every factor that I see in either one of those fractions. So it has to have a 2 and it has to have a 3, but the 2 has to be squared because it was squared in one of those fractions. That makes the least common denominator 12. That's the kind of thinking we're going to have to do with variable expressions. Okay, let's do a couple. So the first step, according to 2 slides ago, the first step is I should factor the denominators. Right? This first one, there's no factoring to do. There's only one term. Can't factor one term. Right? And the second, there's some factoring. What's the common factor? 3x times x plus 1. Now, the least common denominator should have every factor that you see in either one of these denominators. Now, the truth is I could write the 9 like 3 squared, and then that would mean 3 squared has to be in the least common denominator. I mean, you may not resort to that kind of thinking. You might just say, look, between 3 and 9, it's 9. Let's see, there's an x in the first denominator, and there's an x in the second denominator, and there's an x plus 1 in the second denominator. Right? Because the x is actually squared in the first denominator, it needs to be squared in the least common denominator. So here's our least common denominator, 9x squared times x plus 1. What's that? What do you mean, where's it go? Here? It's not gone. It's still there. We haven't done anything yet. All I've done is said, this is the least common denominator is going to be this. Okay. Now, what do I have to multiply? What do I have to multiply the first fraction by so that it has this least common denominator? It has the 9x squared, but it doesn't have the x plus 1. So you've got to put the x plus 1 over x plus 1. Right? What is the second fraction missing? It needs a 3x, right? So I'm going to multiply by 3x and 3x. Basically, I'm just squaring the 3 and the x. Okay, now do both fractions now have the same denominator? They do. So how do we add fractions when they already have the same denominator? You add the numerators. So 7x plus 7 plus 3x squared divided by 9x squared times x plus 1. And just like we did in that last problem where we actually had to factor the numerator, sometimes there's more simplifying to do, and you won't know it unless you simplify it. This one, there's not really simplifying to do in the numerator, but you could write it in standard form, which is usually what you'll see. So the highest degree term would be on the left, right? And then the 7x, and then the 7. Now, it's possible that that trinomial in the numerator is factorable. You would have to check. Is that factorable? How would you check? Yeah, I mean, multiply. 3 times 7 is 21. Can you think of factors of 21 that add up to 7? No, so it's not factorable, so you're done. Okay, so factor the denominators, find the least common denominator, multiply appropriately so that every fraction has that least common denominator, and then add the numerators. I think I got another one. Sure. You good? Okay. Everybody else? Okay, first step. No. Go back. What does it say? What was the first step? Factor the denominators, right? So this one is x plus 2 divided by 2 times x minus 1. And notice that I leave a lot of space to the right of that because I know I'm going to have to multiply by something. And negative 2 minus 1. Factor. How does that factor? Yep. X minus 3 times x minus 1. So the LCD should have every factor that we see in either denominator the most times that we see it. So it should have a 2 and an x minus 1 from the first fraction. And it should have an x minus 3 from the second fraction. Do we need to write x minus 1 again? No. It's in both fractions once, so it's in the LCD once. Okay, what am I going to multiply the first fraction by so that it has, it's missing the x minus 3, right? So multiply by x minus 3 and over x minus 3. And what is the second fraction missing? It's just missing the 2. Right. So now both fractions have a denominator of 2x minus 1, x minus 3. So we need to add the numerators. So that is x squared, I'm going to FOIL this, x squared minus x minus 6. And this is going to be 2 times that and 2 times that, and then it's got to have a minus in front. So what would that be? Negative 4x plus 4x and negative 2 plus 2. Nope. No, I mean, at least there's some like terms in the numerator. We need to deal with that. And then it may be factorable again. So let's see. Negative x plus 4x is 3x. Negative 6 plus 2 is minus 4. So is the numerator factorable? It is factorable. Now, just like in the first homework problem last night, there was we factored the numerator and denominator, but there were no common factors. So what couldn't be simplified anyways. But looking ahead, will there be a common factor if we factor the numerator? Try again. It's actually x plus 4 times x minus 1. So x minus 1 will simplify. So we should keep going. We should write x plus 4, x minus 1, and then we can cancel the x minus 1s. Great. Good. Okay. Slow me down if I'm wrong. So there's your U try. See that much of it? So what do I have to multiply? So what do I have to multiply the first fraction by so it has the same common denominator? 12. 12 over 12. Now what do I have to multiply the second fraction by? X plus 3. Okay. Now at this point, I've seen this happen in the other class too. At this point, don't start canceling factors. right? Because obviously there's some common factors. You just multiplied to create common factors. You don't want to like turn around and cancel them. You want to add the numerators, right? Now that they all have the same denominator, 12x minus 4 times x plus 3, right? Then it'll be 12x plus 15x, no, plus 5x, sorry, plus 5x plus 15, which is 17x plus 15, 5 times 3. Okay? And that's the answer. I mean, you should look at, can you simplify the numerator at all? No. So you're done. Okay, do another one. Come on now. It's good for you. Right? So you should have factored the x plus this as x plus 2 squared. This is x squared is x plus 2 times x minus 2. That's the LCD. So in order that this fraction have the LCD, I multiply by x minus 2 over x minus 2. In order that this fraction has the LCD, I did x plus 2 over x plus 2. Then this is a FOIL. And this negative, and that many people made this mistake, that's negative 6 times x and negative 6 times 2. So both of these are negative. And then combine like terms, and that's it. And is that factorable? Are there factors of negative 14 that add up to negative 7? No. So it's done. And it's common that that's the way you leave your answer, right? Not in any kind of factored form. It's standard form in the numerator, factored form in the denominator. Okay. One more concept. Complex fraction. Complex fraction is a fraction with fractions inside of it. Now, we're used to dealing with fractions, rational expressions. That's what we're doing in this chapter. But we're not used to dealing with fractions that have fractions inside of it. To simplify, we want to just turn it into a rational expression with no more fractions inside of it. So a rational expression is okay, not a complex fraction. And I'm going to call the fractions that are inside the numerator and denominator of the big fraction, I'm calling those inner fractions, just to have something to refer to those by. Peter, pay attention. Doesn't look like it. Good thing you get 100 on every test. Thank you. Okay. So I'm going to do one method and then the other. They don't come in any particular order, but I have a feeling that the way that I'm going to do the first one is probably the way you're going to want to do it, but maybe some will surprise me. So the first method is, if you notice, we have two fractions that are being added. We have a sum of rational expressions in the denominator. Well, that's what we just learned how to simplify, right? So let's do it. Do what we've already learned in this lesson to add these two in this denominator. All right, what would be the LCD of that denominator? The LCD for that denominator only, right, is going to be x plus 4 times x. Okay. So what will I multiply the first fraction by so that it has the least common denominator? I have to do it by x over x. And what will I multiply the second fraction by so that it has least common denominator? X plus 4 over x plus 4. Blue. Add the numerators. X plus 2x plus 8 divided by x times x plus 4. Not yet. So we found the common denominator. Quiet, please. I'm glad you find it funny. We found the least common denominator. We multiplied so that both fractions have it. And then we added together those terms. And then I combined like terms to get this. Okay, now we're left with, we're dividing a fraction, two rational expressions. How did we do that? We just did it in the homework last night. You turn it into a multiplication by flipping that. So do that. Oh, look at that. 5 over x plus 4 times, and now I'm flipping it, so it's x times x plus 4 Okay, so dividing, you change to a multiplication, and then you cancel the common factors. So which are they? Yeah, this x plus 4 cancels with this x plus 4. So this is 5x divided by 3x plus 8. So the advantage of using this method, it's actually just using things we've done recently, right? We just learned how to add fractions. We learned the last lesson how to divide fractions. That's it. So this is not a complex fraction anymore. So that's how you know you're done. Now the second method, it's not that we haven't done it before, but we don't do it a lot. And when we do it, most students seem to avoid it. But that's, if you remember, if you're trying to solve an equation where fractions are involved, if you multiply by the least common denominator of all those fractions and then cancel all the denominators, that's called clearing fractions. And that's another way you can do something like this. But we don't do it as often. And like I said, you might choose to do this rather than that, but I'll show it anyway. I mean, I wish you learned how to clear fractions, but. So, in order to do the second method, we need to find the least common denominator. We need to find least common denominator for all the inner fractions. Right? In this case, in fact, it's going to be the same as the denominator that we already did. So this is x times x plus 4. Right? This is the LCD for all the inner fractions. Okay, and then multiply the numerator and denominator by that. Right. So whatever I multiply the numerator by, I got to multiply the denominator. Ultimately, this is 1, and you're allowed to multiply by 1. Okay, now I'm going to multiply. In this case, it's just one term, but if I multiply 5 over x plus 4 times x plus 4, what cancels? Yeah, the x plus 4s are going to cancel, and I'll get my 5x, which I know is in the final answer, right? Now, here I'm going to have to distribute, right? It'll be this times this, in which case the x plus 4 will cancel. And then it's going to be this times this, in which case the x's are going to cancel. So it'll clear all the denominators of the inner fractions by doing this. So in the numerator it'll be 5x. In the denominator, the first term will be 1x. Yes. X plus 2 times x plus 4. Right? So I'm taking this, and I multiply times that, and then I multiply times that. Right? And this is 5x divided by x plus 2x plus 8, which is 5x divided by 3x plus 8, which was the same answer we got on the last page. Okay, here's your you try.
I did it. No way. I did the first part right, and then the next part I did not. If I did not get this right. I was on the right track. I was so close.
Because I find a least common denominator for the numerator, and then a least common denominator for the denominator. Right? Do one for here and one for here. If I found the least common denominator for all 4 of those fractions, no, it's just one method. It's the first one. What's the least common denominator between 6, 3, 5, and 10? 30. Right? So if you would have multiplied the numerator by 30, the denominator by 30, that would be the second method. But we just found least common denominator for these 2, which is 6, and for these 2, which is 10. multiply by 2 over 2, 2 over 2 to get that. And then those were like terms, so they had to be combined in a negative x over 6. And then dividing by a fraction is like flipping and multiplying. And there was a little bit of simplifying to do here, because 2 goes into 10 and 6. Okay, one more. One more. We're not leaving until everybody gets one right. Okay. No? Okay, are you done now? Taylor, are you done? Okay. So, fallo. Fatelo. So, I did it like, this is the second method, which you probably didn't try to do. But the LCD for all of these is that at the top. So I multiply the numerator and denominator by that. Now, when you multiply the numerator, the x plus 5 in denominator cancels. You just get the 3 times x minus 3. Right? Now, there's two terms here, so you have to distribute. This multiplies times this, which cancels the x minus 3. This multiplies times this, which cancels the x plus 5. And then this is left. And then this is just simplifying that. Let's see. The first method, I'll do over here. Three times x. Let's see, 2 over x minus 3. So the first, if we were going to use the first method, I'd find the LCD between these two, which is the same thing, right? LCD is x minus 3 times x plus 5. So I have to multiply this one by x plus 5 and this one by x minus 3. And now I've got 3 over x plus 5 divided by, these have the same denominator, x minus 3 times x plus 5. And these I've got to do this multiplication, right? That's 2x plus 10 plus x minus 3. So 3 over x plus 5. 3x plus 7. 10 minus 3. Then x minus 3 times x plus 5. Okay, and then how do I go from there? How do we divide fractions? You flip and multiply. So x plus 5 cancel, and 3 times x minus 3 over 3x plus 7, which is the same. Okay, enough silliness.